Hello, good day. My name is Nurul Asmahandi binti Said. Today I will present my research proposal titled Multi-Objective Fire Risk Modeling for Autonomous Vehicles Using Response Surface Methodology. This research focuses on improving fire safety in autonomous electric vehicles by developing a predictive and optimization model. For the introduction, I will explain about the rapid growth of autonomous vehicles, uses of lithium-ion batteries, and the thermal runaway risk. For the autonomous vehicles, right now are rapidly becoming an important part of modern transportation systems. Most of these vehicles uses lithium-ion batteries, which provide high energy efficiency. However, these batteries are also introduce significant safety risks, especially the thermal runaway. Thermal runaway is an uncontrolled reaction that can lead to the fire or explosion. Therefore, understanding and modeling the fire risk in autonomous vehicles is very important for safety improvement. Here are the problem statement. The first one is the existing models are qualitative. The second one is the limited optimization, and the last one need predictive model. Currently, most fire risk models focus only on identifying the causes. These models are mainly qualitative, meaning they describe the problems but do not provide optimized solutions. In addition, they do not fully consider the interaction between important variables such as temperature, charging rate, and the ventilation. As a result, there is a gap in developing a predictive and optimization-based model, which is that can reduce the fire risk effectively. This research aims to address the gap. The main objective of this research is to develop a multi-objective fire risk model using response surface methodology. Specifically, this study aims to first identify the key factors affecting fire risk, and the second one is to develop an RSM-based model to represent these relationships, and the third one to analyze the interaction between variables, and then finally determine the optimal conditions to minimize the fire risk. This objective will help create a systematic approach for the fire safety improvement. The methodology of this research are RSM approach, both backend design, and 3 key factors. This study is guided by 4 main research questions. The first one is, what are the key factors that influence the fire risk in autonomous vehicles? The second one, how do these variables interact with each other? The third one, can response surface methodology effectively model fire risk behavior? And the last one is, what are the optimal operating conditions to minimize the fire hazard? These are the questions provide the foundation for the research. This slide shows the conceptual framework of the study. There are 3 main input variables are battery temperature, charging rate, and the ventilation rate. These factors directly influence the output, which is the fire risk, measured in terms of fire probability and heat release rate. This framework helps visualize how operational parameter contributes to the fire hazards. It also supports the development of structured and systematic model. This conceptual framework illustrates how key operational parameters influence fire risk outcome in autonomous vehicles. This slide presents the research methodology using response surface methodology, or RSM. First, the important factors are selected. The second one, the experiment design is created using box backend design. The third one, experimental runs are conducted using simulation or data. The fourth one, a mathematical model is developed to represent the relationship. And finally, the results are analyzed and optimized. This approach will allow both modeling and optimization at the same time. This methodology ensures a systematic and efficient approach to identify optimal conditions for minimizing the fire risk. In this study, there are three key factors are used: battery temperature, charging rate, and ventilation rate. Two main responses are analyzed: the fire probability and heat release rate. Both responses are minimized as part of the optimization process. A second-order polynomial model is used to describe the relationship between variables. This allows us to capture both individual and interaction effects. The expected outcome of this research is to include identifying the most critical fire risk factors. The study will also develop a predictive model that can estimate fire risk under different conditions. Most importantly, it will determine the optimal operating condition that minimize the fire probability and severity. These results will help improve safety in autonomous vehicle system. This research has both academic and practical significance. Academically, it contributes to the field of fire safety engineering by applying optimization techniques like RSM. Practically, it supports the development of safer battery management system and vehicle design. And ultimately, it helps reduce the fire incident and improve the reliability of autonomous vehicles. In the conclusion, this research proposed a systematic approach to model and optimize fire risk in autonomous vehicles. By using response surface methodology, it is possible to identify key variables and determine the optimal conditions. This contributes to the safer and more reliable autonomous vehicle system. Thank you so much for your attention.